Hello everyone, I am Aswani, Assistant Professor, Department of CSE AIML at MLR Institute of Technology. Welcome back another session of Artificial Intelligence. In this today's session, we are going to learn about uncertainty measure in AI. Let's see the overview of this session. Uncertainty in AI, probabilistic reasoning and examples of probabilistic logic. Let's see what is uncertainty AI. So agents in real environment are inevitable forced to make decisions based on the incomplete information, incomplete data. Even when an agent sends the world to find out more information, it rarely finds out the exact state of that world. So here what happens, agent can't sense or can't guarantee that 100% that statement is true. There is some certain uncertainty is there in that statement. For example, a doctor doesn't know exactly what is going on inside a patient. Likewise, a teacher doesn't know exactly what a student understand, or a robot doesn't know what is in room it left a few minutes ago. When an intelligent agent must act, it has to use whatever information it has. Based upon that information only, it will draw the conclusions. So, what is the big sources? So, what are the major sources of this uncertainty? Uncertainty is the biggest source of difficulty for beginners in machine learning, especially developers. So, the resources of this uncertainty is noise, data, incomplete coverage of the domain, and imperfect models provide these three main sources of uncertainty in machine learning. So probability provides the foundation and tools quantifying and handling, harnessing uncertainty in applied machine learning. So these are the major sources. Then how we can measure that uncertainty by using the probability. Let's see. So here the uncertainty is defined as lack of exact information or knowledge that help us to find the correct conclusion. So what are the sources? Uncertainty input, missing data and noise data. Uncertainty knowledge. Multiple causes lead to multiple effects. Incomplete knowledge of causality in the domain. If we are having incomplete data, then of course will leads to the incorrect result. Uncertainty output, default reasoning, incomplete detection and inference also. Next, uncertainty may be caused by problems such as missing and unavailable data and unreliable ambiguous data, inconsistent data, guess data and default data. These are the problems for uncertainty. Let's see how we can measure that uncertainty for a statement. That is a probabilistic reasoning. The probabilistic reasoning is a way of knowledge representation where we apply the concept of probability to indicate the uncertainty in knowledge. So in probabilistic reasoning, we combine probability theory with the logic to handle the uncertainty. We use probability in probabilistic reasoning because it provides a way to handle uncertainty that is result of someone's laziness and ignorance. So the probabilistic reasoning means it is the combination of probability theory and logic. Then by using this probabilistic reasoning, we can measure how much of uncertainty for a particular knowledge. For example, we can say it will rain today, behavior of someone for some situation, a match between two teams or two players. If you observe in the IPL also, there is a prediction of a score. So it is not guaranteed that after 20 overs, this is the exact scores before match. So there is some predictions, there is some uncertainty is there in that prediction also. That is the one of the example. So these are probable sentences for which we can assume that it will happen but not sure about it. So there might be a chance to score that much. For example, 199, 188. There is a prediction but not sure about it. So here we use probabilistic reasoning to measure. Okay, 90% this much of score, 90% today it will rain. Like that we can measure the uncertainty in a knowledge. Need of probabilistic reasoning in AI. So when there are unpredictable outcomes, when specifications or possibilities of predicates becomes too large to handle, when an unknown error occurs during an experiment. These are the when we required probabilistic means when unpredictable or specification or possibilities of predicates becomes too large, unknown error will occur. So here in probabilistic reasoning, there are two ways to solve the problems with uncertain knowledge. One is a Bayes rule, another one is a Bayesian statistics. So let's see what is a probability. Probability can be defined as a chance that an uncertain event will occur. Probability means probability can be defined as a chance that an uncertain event will occur. So it is a numerical representation, numerical measure of likelihood that an event will occur. The value of the probability between the range of 0 and 1. So 0 less than or equal to probability of A less than or equal to 1, where probability of A is an event. Probability of A is equal to 0 indicates the total uncertainty of an event A. Probability of A equal to 1 indicates the total certainty in the event A. So how we can find the probability of an uncertain event by uncertain event? So the formula is probability of occurrence equivalent to number of desired outcomes divided by total number of outcomes. So here probability of negation of A equivalent to probability of not happening event. So probability of negation of A plus probability of A is equivalent to 1. So these are the some of the terms which are used in the probabilistic reasoning. The first one is event. Each possible outcome of a variable is called an event. For example, probability of A, probability of B, all these are called as event. Next is sample space, the collection of all possible events. For example, in the previous probability of negation of A, probability of A, all these are the sample space. Next, random variables. Random variables are used to represent the events and objects in the real world. To represent events, we will use the random variables. Prior probability, the prior knowledge about an event. The prior probability of an event is a probability computed before the observing new information. Only prior knowledge about that event is occurring. Next, posterior probability is the combination of prior probability and new information. The probability that is calculated after all evidence or information has taken into account. It is a combination of prior probability and new information. These are the terms which are usually used in the probabilistic reasoning. Let's see, conditional probability. Conditional probability is a probability of occurring an event when other event has already occurred, already happened. Let's suppose we want to calculate an event A when event B has already occurred. Event B is already happened, but we want to find out the event A. The probability of A under the condition of B, it can be rewritten as probability of A given B. B already happened, we need to find out the probability of A. So, probability of A given B equivalent to probability of A and B divided by probability of B, where probability of A and B is a joint probability of A and B. Probability of B is called as marginal probability of B. So, if the probability of A given and we need to find out the probability of B, then it will be written as vice versa. Probability of B given A equivalent to probability of A and B divided by probability of A. So, we can derive this using Venn diagram where B is occurred event. So, sample space will be reduced to set B, and now we can only calculate event A when event B is already occurred by dividing the probability of A and B by probability of B. So, we want to calculate probability of A, then probability of A and B divided by probability of B. Then we can find out the probability of A. Let's see one example. In a class, there are 70% of the students who like English and 40% of the students who like English and mathematics. And then what is the percent of students, those who like English also like mathematics? So, let A is an event that student likes mathematics. So, B is an event that a student like English. Now we need to find out probability of A given B. The formula already we have seen. Probability of A and B divided by probability of B. Probability of A and B equal to 40%. 40% of the students who likes English and mathematics, 70% of students who only likes English. So 0.4 divided by 0.7, then 57%. Hence 57% of the students who like English also likes mathematics. In such a way we can derive the probability. So in this session we have seen uncertainty. What is uncertainty in AI? What are the major resources of uncertainty? What is the probabilistic reasoning? What are the terms in probabilistic reasoning, such as event, sample space, random variables, prior probability, posterior probability? And what is the conditional probability? What is the formula for conditional probability? And we have seen one example for this. Thank you.